Hello everybody. In this video, we get to finally talk about how to find the derivatives of my more general exponential functions and my more general logarithmic functions. Remember, we know how to find the derivatives of the specific exponential function e to the x, right? E is a very specific number, and if I take that derivative, I just get itself. I also know the derivative of the natural log of x, right? Log base e, and that just gave me 1 over x. So can I take those derivative rules and somehow extend them to exponential functions with any base or a logarithmic function with any base? Well, it turns out you can't. Let's say I want to take the derivative of a to the x. Now that I understand exponential functions and logarithmic functions better, I can use a little bit of algebraic manipulation here to rewrite this as a is equal to e to the natural log of a. We know that e and natural log are inverse functions, so those things effectively just cancel out. And so that's an equivalent expression. But being able to write it like that, I can now use an exponent property to rewrite this as e to the natural log of a times x. Now that I'm back to base e, I can use my exponential formula that we learned earlier in this section. If I have e to the k times x, natural log of a is just a constant. That's something you can plug into your calculator. So I'm going to treat it as a constant here. When I take my derivative, I just get my constant, natural log of a, multiplied by my original function, e to the natural log of a times x. This isn't very pretty, so I have to go back and recognize, hey, what is this again? Since this is the same exact function that I started with, I can go back and rewrite that as just a to the x. And so I'm left with the natural log of a times a to the x. So, not too complicated of a formula. If I want to take the derivative of an exponential function with any base, you just get the natural log of whatever the base is multiplied by a to the x. Well, what about log base a of x? So a logarithm with base a. Now this is where we're going to use that same process we did with the natural log of x to work through this one. I'm going to say log base a of x. I'm going to set that equal to y. And then I'm going to use my definition of a logarithm to rewrite this. A to the y is equal to x. That's what a logarithmic function does. It asks the question, what power do I need to raise a to in order to get x? And now that I do that, I can take the derivative of both sides. Remember, based off of what we just talked about, I now know how to find this derivative. Now that I have a derivative rule for the derivative of an exponential function with any base, I can work through this process now. So when I do the derivative of a to the y, I get natural log of a times a to the y. That's based off of my rule that I just came up with. But remember, this requires implicit differentiation because this is y, and I'm taking the derivative in terms of x. So I'm going to multiply this by dy over dx. Or y prime. Remember, you can use either one. Well, what about the other side? The derivative of x is just 1. And now I can solve for my derivative. I get 1 over the natural log of a times a to the y. Well, what's a to the y again? That comes back to what we said right here. A to the y is just equal to x. So 1 over natural log of a times x. So, once again, now that we know all these other rules, finding that derivative is relatively simple, and so now I have my next derivative rule. The derivative of log base a of x is just 1 over the natural log of a times x. Notice how that's similar to my natural log rule. All I'm adding is an extra natural log of a in the denominator. So these are my two new derivative rules for this section. And of course, we'll run through some examples in the example video, but this is just the basic concept behind it. So once again, go ahead and try out some homework problems, just knowing that basic concept. And then if you get stuck, go watch the examples video. But there is one more thing I want to talk about before I let you guys go, and that's just we need to make sure now that we're dealing with any base, with e it was pretty easy to recognize when something was exponential, but now that I'm not limited to just base e, we need to make sure and tell the difference between a power function and an exponential function. An exponential function, which is what we're talking about in this section. You have a fixed number as your base, and the variable is up in the exponent. You might have a function up there, which would require chain rule, right? But the idea here is that the variable is in the exponent and your base is fixed. That's much different than a power function. A power function is the exact opposite, where your variable is the base that's being raised to a power, and that power is fixed. So hopefully you can see the difference between these two. The homework likes to throw both at you so that you have that chance to distinguish which one requires the power rule and which one requires my exponent rules. Any function in this form is going to use this new derivative rule that we just learned. But anything in this form, anything that's a power function, is going to use that rule where if you have x to the p, then your derivative is p times x to the p minus 1. So that's probably going to be the biggest thing that'll trip you up. Don't confuse exponential functions with power functions and vice versa. Okay, good luck. And once again, once you get stuck, come check out the examples video. Thanks.